Hello and welcome to Optimizing Picking and Packaging Applications with KUKA PickControl. Key takeaways of this webinar include an overview of conveyor technology, understanding cycle times, effective load distribution, processes and best practices, custom stacking options. My name is Jules Romeo and I'll be your host for this webinar. Thank you for joining us today to hear Chad Ducart, Senior Sales Application Engineer from KUKA Robotics. If you have questions for the presenter, please feel free to type them in the questions tab on your screen, and we will address as many as possible at the end of the presentation. Now, let's hear from Chad.
All right, thank you, Jules, for that warm welcome. Everyone excited to be here? Yeah, I'm really excited about this product. It's one of my main focuses. Some others, conveyor tech and pallet tech, others like that. But this is one of my main ones, and I'll tell you what I know about it. So we'll get started. So let's talk a little bit about what pick control is. Pick control is just an easy way to coordinate between multiple robots in a high-speed picking line using conveyor tracking. The robot tracks parts and then places them usually into some kind of container. We'll talk more about that in a bit here. Okay, so the part we're focusing on today is more the pick and pack side of it, not the palletizing side. And I see my slides are not starting here for some reason. There they go. They are starting now. So when we talk about the pick and packaging side, we have some type of inbound conveyor. So this would be my inbound conveyor with parts coming down the conveyor, maybe randomly, maybe in a straight line. And then we want to take those parts and then stick them into some type of container. Maybe it's chocolates that we're palletizing or moving back and forth. We can use various types of robots. We have our Agilis robot here, our Delta, and then Scaras. And most times, if not all the time, we have our external resolvers here that tell us where the packages or where the containers are on this side. Also on the inbound side, they tell us where each of these packages are based on a vision system. So we get an X, Y, and maybe some type of rotation. We also have another resolver here, but you don't have to use a resolver. You can do it a couple different ways with your own external encoders also. And then we have some kind of trigger switches, what the proc switch is showing down here, because we need to find out where the leading edge of that container is at, or the same goes here as we need to know where that package is at so we can go pick it up. And this uses the KRC5 controller, the -1 controller, and then this is showing an IPC. Here we use this to help us out with the vision system side of it. So moving on here, oops, did I skip a slide? I did skip a slide. So as far as the software goes, the example here is 3 robots. We have a master and then 2 slaves, but it can support up to 10 different robots, or 10, 1 master and 9 devices. And each of these robots have some working area. So here we're palletizing these cubes here in this form of this KUKA logo. Also, there is it is on 8.7 software, so 8.6 is not supported, just the 8.7 software. There's a couple different flavors. The Pick Control Master here would integrate the KUKA Vision in it, but we can also just have a master robot with some other external sensor or SDK, this development kit that we provide. And then just basic software for the number of slaves that you need. So minimal amount of pick control software there. And it's suitable for any of these machines, but it can also take the big machines also, even run a Titan if you want to. So the 2 videos that I want to show are the first 2 here of some basic pick control applications that you see out on YouTube. So I'll start those videos now. We won't watch the whole video, but some pieces and parts. You can find these out on YouTube if you'd like. So 3 robots picking parts off a conveyor. There's a vision system on the back side here that you'll see in a second. So they're randomly defined. No orientation control here because they're just round hockey pucks. So here's the vision up in the front that's processing the parts and giving the information to the 2, or I guess in this case, 3 robots. And just some different software that we have. We'll talk about these pieces. This is how we define that whole KUKA logo there in software. So lots of different control there. The whole idea of this software is I minimize. I don't have to teach all those points. They're all calculated for me. All right. Next one here I want to show is the spoon palletizing. This one was done in India, and I'm picking up these plastic spoons that are here. And I'm going to jump forward here to, we don't need to watch this whole video, the important things that I need to show. Oops. Somewhere in here. Here it shows the whole machine picking and placing the product. So 1 spoon goes in each of the protein bags that are there. And then I want to jump forward here to some of the setup to show that. So this tracking part, the vision system that's there, and should be right after this, some of the calibration fixtures that are used. Yeah, so the pointer is taken out, and then we use this calibration plate here. This is mostly used for the vision, but you use a similar calibration point to define a start location where you want to start, and then 3 points on the conveyor that defines where the parts are at, or the angles and the frame that's defined there. That's what he's showing here, is teaching those 3 different positions. And vision is actually shown on the pendant. So we'll stop that and continue on. The other items that are here are some of our setup videos on how to set the software up. There's a full video that shows you pretty much from start to end. And then some other marketplace items and the manual, which we'll go over here. Okay. Next section here is how to define the configuration. Everything is done in Work Visual, and you'll see this object structure. We'll spend a lot of time in here showing that, and then the definition, or this tracer view, as it's called. There's also guided wizards to set up all the sensors, light barriers, conveyor positions, where we figure out what the transmission ratio is based on starting and stopping the conveyor, so that it smoothly picks and places how it needs to. And then the different scenarios. So these scenarios, another word for this would be recipes. So that's what the production scenarios are called here. And we'll just jump forward here. We'll show more details on this a little bit later. All right, so some of the software components that are there, we use our PC and we configure everything in Work Visual. We also have an IPC for the Pick Control Master. So if we had 5 robots, we'd have 5 of these different machines, R1 through R5, and then we'd have an IPC also. So the whole project and all the configuration also goes down to this Pick Control Master. So it knows where everything's at. So we can nicely see all the production information on this tracer view. It's a very nice tool. Love that tool. It helps a lot. And a bunch more diagnostics. So on the robot side, on the controller, we have the Pick Control wizards that teach all my positions for me. We also have a PLC, a soft PLC, Procanos that's running there that you would communicate to use PAC-ML to control all the robots. And we'll talk about PAC-ML a little bit later. The KRL is there, and then a conveyor driver that's run through PickControl. So. And then on the vision side, we have a full Cognex library there that works quite well. That gives you all kinds of vision capabilities. Inspection, measuring, pretty much the whole thing. So as far as the robots that we have a Delta machine that's IP69. You can see all these on the website. And then we have a composite machine also. Oops. Which is right there. And this has the HO oil. So a little bit cheaper machine, not all stainless. All right, some of the key features here is the tracer view. As I talked about, one really nice thing that this does is this allows you to define all your scenarios and all your products, how they're going to be packaged. And then you can test this out very early on. You don't have to wait for the PLC guy to do all this work. If you are the PLC guy, you still don't have to wait for all this. You can kind of test this out and make sure this all works. Make sure you get all your material flowing through. You can pick your product, place your product. So very, very nice tracer view. Very, very good tool to use. And then the communications is definitely has to be PLC controlled. And I would not recommend that you not have a PLC. It can be done through the submit. We have done it before, but I think it's better if you have a PLC. Just there's so many parameters that you can change here, and you want to be able to do that from a PLC HMI, not from the pendant if you can avoid it. It's already got the DLIN or our fast motion type in it, and then it's dynamic load sharing is a great feature. You know, if I got 10 robots, which robots get which data or which parts. Flexibility. Vision, we have a SDK that you can use to define your own vision system. So very wide open system, good system. Moving on, can be used in lots of different areas, fast moving consumer goods, also automotive. I'll show some examples of that in a little bit here. Okay, gripping and sorting parts, mixed parts. You kind of name how you want to do the system. It's very flexible in that respect, but does have some limitations as far as, you know, picking up parts at 90 degrees. You know, you can consult with us if those special things need to be done. It does support 10 robots and 3 working areas per robot, so I can have 3 conveyors. And if you're using your own IPC or industrial computer, you may want to check with us. Can be done though. And no PLC, as I said earlier, you probably want to have a PLC in the system. So these are some of the questions you'd probably be asking, you know, number of conveyors, and we do have help. I'm one of the main persons in the US, but we do have also international help too. All right, so let's move on to how we do things in WorkVisual. So this is a sample that's defined in the software here. If we go to the PickControl section and under documentation and the WorkVisual samples, this sample that I have here is this 01 sample. And the last one is a simulation. So we'll go through each of those now. So this sample is defines 2 robots, 2 conveyors, a vision system, and a light barrier. So this document pretty much shows you how to create this whole template if you want to know more details about things here. Yeah, so 1 camera and 1 light barrier. And it kind of takes you through step by step of what you have to do. So we'll just jump forward here a little bit. And this distribution is how we define what robots get what. And I'll show you some examples of that too. But all this is explained in this 13-page document. And then This is one robot, one conveyor, one camera, one light barrier, and one fixed location. So what the fixed location is it's something that doesn't move. And then the last one is just a basic simulation. And I'll show an example of this working and running just a little bit later. So those are the 4 samples that are defined. And one thing I want to also show here is there are some KRL samples too, if anyone's interested. Okay, so first thing is the pick control object structure. When I hit this button up here, that's what we're showing. And then the next one is the cell view. So when you define a cell, we have also the cell configuration. So we'll go back to the, what I want to show here is there's multiple conveyors. These are the KUKA conveyors that you have with the resolver, but you can also add external conveyors also that are controlled by a PLC, maybe over Profinet, or just your own encoder feedback type conveyor. So other possibilities are there. And then there's a way to generate all the code. That last button there generates the code so that you can use that on your IPC. All right, so we will, so the object structure here, this defines what kind of product you're picking up, and this happens to be chocolate, 20 by 20 by 10. And once we open this up here, it comes up with a dialog box. Pretty much all these things have dialog boxes. And you can load your own image in here. So we'll stop it here and I'll ask my first question. Since no one's asking any questions, or maybe we don't know if there's any questions. Do you prefer T-bone or ribeye is my first question to you, or do you like green peppers? So you can write in the chat. Jules will tally those up. I know it's after lunch. Maybe some of the West Coast people, it's not after your lunch. So maybe I'm making you hungry. Sorry, but my choice is ribeye if I had to pick. Jules?
I would say ribeye. Everyone else, go ahead and put your answers in the chat, or you can even send it in as a question so I can tally those up.
All right, well, I'll continue on while you're tallying those up, Jules. Okay, so you can pick your image here. We picked chocolate for this since that's what we're going to be moving around. The tray is going to consist of a bunch of chocolates. Should be like a 5 by 5 matrix, so 25 different items and how they're arranged. So you pick and choose your X, Y, and Z. And there's ways to generate these automatically so you don't have to type all 25 of these in. This is done pretty dang well. I like how this works. So that's what we're showing here. And then it just goes, you define the order, but it doesn't necessarily have to use that order either. So once you hit the start and stop, it'll show you how it's palletizing those products. And there's a rotational, so you can actually see how it's going to be placed on that conveyor. Okay, and what this is showing here is when I right click, I guess I'm not right clicking here. There's conveyor 1, conveyor 2, and I have a resolver on each of these. I have a camera, and then I have pick zones for robot 1 and robot 2 of where it's going to go. The light barrier there is for the tray. So here's the drive configuration. All our resolvers go in the back of the robot. So this would be the master, and it would have 2 resolvers going in the back. So that's what this is showing, and the conveyors below it there. So that's our position tracker. And then as I think I talked about this earlier, these other 2 types of conveyors are a Profinet conveyor, and then you can define some type of resolver, or not a resolver, but a encoder type input. So there's definitely some choices there. All right, and what's next here? Okay, sensors. there's our camera, and we've got a task always to detect our chocolates, and then our light barrier also has a task to detect the tray for us. And those go into our fast inputs. The double click there shows the distribution rule. So in this case, we got 2 robots and they're both taking 50% load. Could be a different type of load, and if it can't do it on the first robot, then it automatically goes to the second robot. And then this is showing the second part of it on the second conveyor. Conveyor number 2. What's the load distribution? Again, 50-50. And I'll just divvy those up as it needs. Okay, so the last item here is how are our scenarios done, or what do the recipes look like? You can create new ones, you can duplicate them. I would suggest that you get the first one working properly and then go from there. These are the work areas. You define a number here in millimeters from the origin of the robot, left and right. Well, that's that number that it's showing there. And then the same for the other robot. So we have 4 work areas. Okay, now we show the material flow. And this is, if we have a camera and a trigger distance, this first conveyor shows us what the material flow is going to be. So we're picking product here. That robot job is the pick. And then we have our distribution of 50-50 that we defined earlier, or that you saw earlier. And we're detecting chocolates. The object is the chocolate. Okay, and then we define on the second conveyor, the tray is I/O triggered with a trigger switch, a fast input. And we're going to detect the tray, display the tray, and the object that's going into the tray is the chocolate. And that's our placing routine. So the pick and place are pretty much all canned and defined. Not many points that you have to teach. So very nice system. And then the second one there is if the trays don't quite finish in the right amount of time, we have to tell it that it can bypass that. So that's what that last line item is there, this one right here. This is also I/O triggered. So we must have that, or it won't work and it gives you an error when you build the project. I'll jump forward here a little bit. Hardware, just showing all the defined hardware that we need there. Conveyors, robots. And then the last item there, the IPC. This is the IPC, or the IPC address of the hardware. So we have to send a project to the IPC so it knows about everything. Okay, and the last item is a simulation. Of course, you want to see how this product is going to work. We'll show that in a minute, but before you do this, you have to build the project. So I'm closing some windows here. And everything is saved, and now I'm going to build the project. Oh no, there's going to be a problem, I have a feeling. Yep, there is. It didn't build. Why is that? So we double click on it, and you can see here that we didn't set this output. So we need to make sure that controller 1 goes to our trigger, goes to a fast input. So that's what those 2 are there. Now we should be able to build the project, and it should work. And what you're going to do is once you do this, you're going to send both projects to each robot, and then the IPC master also needs a project. So that's what that other button would do. And we'll move on to the simulation. So once this is built and working, we can go use our simulation, or it's like a modified tracer view, and that's what this is going to show. So for each of our conveyors, we're going to define a velocity. So we got 160 millimeters per second, and then we need to tell it how we want it to generate objects. So we're going to generate chocolate here, and the position is going to be 150 millimeters away, and then it's going to rotate that by 30 millimeters plus or minus. So we have random products that's going to be coming down on that first conveyor. And then the next thing we'll have to do is we'll go to conveyor number 2 here and do the same for the tray. That's this tray that's here. And we're going to run at 42 millimeters per second. And this is just going to be an offset of 150 degrees. No random spot on the second conveyor. And as soon as all those parameters are set, we should be able to start the simulation. So we press the start here. I guess we're going to look at, this is a very important point. So the execution time here, so this is 500 milliseconds or a half second. That's how long it's going to take us to pick and place product. And why this is important is this is going to kind of dictate our cycle time. So we need to have some idea of what that cycle time is going to be, maybe just estimated, but you can play around with these numbers and kind of figure out where you need to be for the cycle time. Now we're going to press start, and it's going to do this simulation based on all the parameters that we've defined. Takes a little bit of time to start here. And I'm going to go look at the statistics, and the number I want to see is how many dropped trays that we're not going to be able to fill. That's the most important to me. And we got 160. If you see on the right hand side here, we got 160 for conveyor 1 and 42 millimeters per second on conveyor 2. So our product's flowing down randomly. We define that random offset, and robot 1 is picking and placing. You can kind of see it here, hopefully on the video, but you see there's a little dot here. That green dot says I'm picking and placing, and then it places product in here. The entry and exit limits that are set up and defined for the product so it can reach them. Entry and exit limits. So the green and the red is what that's showing. And then we're going to speed up the inbound conveyor a little bit. We're going to slow it down, I guess, not speed it up. And we're probably going to go faster here, I think is what I defined, or we're going to go to 44. And does it miss? Does it miss any rejected jobs here? So right now we don't have any rejected jobs. The reason we have 62 above on conveyor 1 is because we're not always picking and placing all the time. So we miss some of those products. That's why they're orange. And looks like we made it there. This one's probably going to miss. Maybe we got to jump the speed up a little bit more. See if we miss some here. I bet we're going to miss some. There we go. We missed some. So we should see some numbers pop in here, and we probably do. So if we move a little bit slower, maybe we'll make it. So you can do all these what if scenarios here very nicely. So we slowed the conveyor down a little bit. You can see we're still missing some products. We had an orange one there. Okay, and now we're going to stop, and we're going to go change the pick time. We go to that robot task up there. As soon as it stops here, we double click on it, and we can change this. We'll change it down to, how about 350? So it can pick a little faster, and therefore it should be able to place faster. So that's where you set your pick and place time. And we jumped that up to 44 millimeters per second. Jumped our conveyor speed up a little bit. And you can see the dot signifying, so it should be a little bit faster now. And you can see by that picking time, that really fills this up. It's way ahead. Yeah, quite a bit faster. And we should easily make the rate here. It looks like we're way ahead. And we have not missed any jobs yet, it doesn't look like. So we can jump that speed up. We'll go to 47 millimeters per second, and we should probably start losing some now. Yeah, I bet we're going to lose some right here. Oh, maybe the next one. But you can still see we have no rejected jobs on the outbound. Are we going to lose some? Well, eventually we'll probably lose some. Okay, so the next section is the example number 4 here, and this is simulation only on the 04 sample. And you can see one thing you see here is there's nothing defined here. So one thing about this is just a simulation, and I personally don't like to do it this way because then I don't have any real cell. When I create this cell, I can download this whole project to the robot controller when I get it, and everything should be set up and working and functioning for the most part. I'll still probably have to play around a lot in the real world with gripper times and scenarios and exit and entry zones, but still I can do a lot of this work up front. So let's show the simulation here. So here's our T-bone steaks. And this is a little bit different system, one robot only, an in-feed station, and then a pallet station. So this one is defined. All right, Jules, do we have some numbers for my questions, or?
I'm going to say that ribeye was the winner. We had a couple come in.
Oh, great group here, for sure. That's my favorite too. Love the spinalis around the outside on a ribeye. Can't beat it. T-bones, too much work. Way too much work. How about you, Jules? What'd you pick?
I think I'm going to go with ribeye. I think that's
Okay.
a solid answer.
Good choice. I bet you're just saying that because I said it, right?
No, it's a good one.
Okay. Okay. All right. Let's continue on here. You guys sidetracked me with the meat. All right. So what this is showing is the T-bone steak here, and I have 3 packages this time that go into a carton. So I'm picking one ribeye and then sticking it into this package of 3. 3 is always better than 1, right? But these are T-bones, and there's my image that I can stick in there so it looks nice and cool. Maybe I give this to my end customer to use. And let's just jump forward here a little bit. So there I have my tray coming in with 3, and then I have my ribeyes up here. And notice one thing here that I didn't talk about is this turns red, and that's because it stopped this conveyor. So I have control to stop this outbound conveyor. So once it sticks these in here, it does these really fast. I think these are set to 50 milliseconds. Very unrealistic, but you can change that number to whatever you want. And then once it fills that tray, it moves on. And this can also place these in this tray automatically on the fly here too. So it can be moving. So that's what that's showing. All right. You guys probably get the idea here. And I also have my camera up here scanning the product. So we'll just jump forward here a little bit. And one of the last items is there's also a checklist that asks lots of different questions. We've developed this just because this application can be crazy sometimes on what people want to do with it. Kind of talks about how many parts per minute, what kind of gripper I'm using. And I don't need just to pick one product. I can pick 3, 5, but I do have to do some customizing in KRL code if I want to do that. What's my trigger source, light barrier, or vision system? Vision, 2D, 3D, all these items. And then the last section is, do I have extra light that's coming in, with vision? Light sources are always very important. Do I need to put the vision camera in a box so that I don't have any other shadows? All right. And the next section here is some examples. So what this is showing is our demo system that we have in Shelby Township. So I've got a robot that's picking these poker chips with pictures on them. And then I've got 2 deltas and 1 Scara. We'll stop it here. And this is the inbound conveyor where these are randomly coming down here on this conveyor, and these two guys know the location from the vision system. You can kind of see the light here. It's up above, you can't see it. And they place these products in a row here, 3 in a row, and then this SCARA that's here picks these up and places these in a tray that I'll show a little bit later. And this is conveyor number 3, so we can support up to 3 conveyors, and each of these conveyors also have resolvers on the end. I think the resolver's up here on this guy, and then there's a resolver right over back here. This is mostly just used for overflow. If this conveyor, you can't move product into these trays, they're full, then it starts dumping them over here, and I think that's what you'll see. So doesn't give you the full picture of the SCARA running here, but you probably get the idea. And then these are dumping back to this first robot to make a cycle. We've taken this to several trade shows. People seem to like it. So we'll jump forward here a little bit and show the last robot. So these are these trays moving in and out of the system. So what's happening here is this SCARA up here is placing these 3 in here, and I think it does 4 layers deep or 5 layers deep, and then fills this tray completely up. So that's what it's doing. And then puts it in the stack of tray, and there's a KMR, KUKA KMR, that takes these products away. So that's that. And I want to show the PickControl tracer here, the tracer view. So this is of that actual cell. So what's happening here, let's go back just a little bit here. Very important part here. So what this shows is the different scenarios. So there was 3 different scenarios for this, picking product from conveyor 1 to conveyor 2, conveyor 3, and we're using just the first scenario. So this tracer view allows you to pick those scenarios because I've defined those scenarios, and I can do this all before the PLC is ready. So what this is showing here is each of these statuses of these 5 robots change. So I cleared them. They should go from aborted to some other state, stopped. And it's easy way, we call this PAC-ML. This is a standard that a lot of the bigger packaging and palletizing companies use to define all these states, state machine. This is documented in the manual also. Now they went to idle, and now what should happen is when I hit start, they should all start up automatically. So this is using our automatic external function, but I don't have to do a lot of work to make this run, and I can do it from this tool. So great, great tool. So now the packages are coming in on conveyor 2 here, or fake package. We're just placing on the conveyor, so we don't really have a real package there, but to the software we do. And then we're waiting for parts here, the little parts in here, and you'll see those come here in just a second. We will bump this up a little bit because it's pretty tedious, 10 minutes of this. So there's our packages, and you can see the orange dot here of when it's doing its placing. And this robot's decided I need to stop the conveyor because I got to fill it up. So that's what it's doing right now. It's filling all these spots. It has to fill all 3 of these spots so they don't go off the end of the conveyor. Now it's green, it's running. This guy is not able to stop the line, but robot 3 is. So placing, picking. Now it's star for product. So as soon as this package here gets down to the end, it should stop it. So it should stop it, right about there. So it stopped it, and now it's waiting for product. This guy stole my piece, and you should see it grabbing some more here. I'll just jump it forward a little bit. Now we got a bunch of product coming. So it should be filling those up. And then also what's happening over here on this one is I'm putting product in here. And remember, it has to stack 4 or 5 high. So then we see the icon change. And we should see that icon change maybe after 4 or 5. I don't remember what it was. So 1, 2, 3, 4. It should put a dot in there, and it did. So put that dot in there. And the other robot here, this last loading robot, took this away, and it's got a tray ready. So this is what we call the stationary loading spot. They don't actually move. So once that's done here, we'll see that last dot go in there, and it should be taken away. Oh, it's not moving now. Let's give it some, we'll jump the video forward here a little bit. There's some more product for you. Robot 3, start filling up. And there's some more product. You guys probably get the idea. And then that last one filled up, and now it should be stacking product over here. Yep, there it goes. All right, we will move forward. Unless somebody really wants to see that, you can put that in the chat, but you probably don't. So we will move forward. And the next thing I want to show is some different ways to use pick control. And here we go. So what this system is, it's in an automotive facility, and it's using pick control to pick these doors. Well, these doors aren't really chocolate, or I mean, they are pretty flat, but we're going to have to rack them in here, and this is going to take some custom code. So what's done is we use the pick control to pick the products because we have 2 robots in here. We have 2 robots on the other side also. So we pick it, and then we can just use our own Carol routines here to place this stuff in here. We don't have to use the pick control to do that. So that's how this one's done. Kind of a cool application. Big old console robot with long reaches, big tools too. Okay, that is the end of my presentation, and we're at 42 minutes. Jules, we got some questions. Maybe she's sleeping, no? Hello? Jules, I'm not hearing you.
Can you hear me on my side?
Sorry, yeah, my Bluetooth must have just died. Can you hear me now?
I can hear you.
Okay.
All right, I'll go ahead and ask that question. What is the difference between using KUKA.sim and Work Visual for simulation?
All right, can you repeat the question? I'm sorry, I can barely hear you on my speakers here.
No, you're good. What is the difference between using KUKA.sim and Work Visual for simulation?
Okay, very good question. The difference is the way the pick control works is it uses it's like RoboTeam, and it uses what's called a precision time control to find out where things are on the infeed and the pallet stations. So KUKA Sim doesn't really support that protocol. So in our next version, it probably will, but today it doesn't. So we have to use this tool to do our simulation. It's the way we have today.
All right. Someone wrote in, if there's an error between the TCP to ProCon connection, is there a way to reset/retry the network connection from the pendant?
Could you repeat the question one more time?
Yeah. If there is an error between the TCP to ProCon connection, is there a way to reset/retry the network connection from the pendant?
No, you have to use the PAC-ML to recover from these errors. So you do have to use you cannot, because also because the robots are in external mode too. So that's the other reason. So you don't really have control on the pendants. It's all done through the PAC-ML.
All right, thank you.
But
Another
good
one
question.
here.
Very good question.
Why does the +Z go into the conveyor and not straight up?
Oh man, who asked that question? Good question. The reason is because the camera is mounted above, and we're always using our offsets in the camera space. So that's why we define the plus Z down through the conveyor. So yeah, excellent question. Man, just got some good ones.
Another one, what hardware do you need to purchase through KUKA for
Okay.
this, I believe?
Could you repeat the question again? What
Is there a
hardware?
hardware that needs to be purchased for this?
Yes. Okay, so the hardware that needs to be purchased is the resolver, because this is a KUKA resolver, but it's part of the package that you get. And if you're using the KUKA Vision, it would be the KUKA Vision part. And there's some licenses, software licenses, of course. Anything else? Trigger, you can use your own triggers. Just those pieces. Some cables too for the resolvers. We provide the cables that go in the back of the robot. There's a whole package with this. Another
All
excellent
right, thank
question.
you. Another one, how much KRL programming do I have to do?
Okay. All right. So hopefully none, but very very little anyway. We give most of the templates with it. If you want, if the example that I showed with the robots with the car parts, that application there, you're going to have to do some custom programming on the placing, but the picking you can use the standard routines. If you need to pick, 5 or 6 packages at a time instead of one, you're going to have to do some work there. But we do provide documentation on that. Let me just show that, because that's a really good question. So what I'm showing on the screen now is the pick control document. And if we go to the section on the programming, these functions are all defined here. The init, using the fixed workbase, all of these are pretty much defined here in what has to be done. So the idea is very, very little programming. That's always the goal.
Awesome.
But you do have to define things like the valves for your particular gripper, that kind of stuff, which would be expected. All right.
All right.
Next.
It looks like we have just one more here. How do I calibrate all robots to inbound and outbound conveyors, vision, trigger switches, and fixed works locations?
Oh, another good question. So the way I do that is I have sorry, lost my train of thought here. If we look in the manual, let's go back. I think, yeah, so there's a calibration section here. So we do this like around, calibrating the conveyor. I think there's a good picture. Yeah, right here's the picture I'm looking for. So to calibrate the conveyor, we have to teach these 3 points. And what these 3 points do for us is they define the origin of where the conveyor's at and what the speed of this conveyor is for the gear ratios. So that's what these 2 points do here. And then the third one just defines that frame as the part's coming down. As far as the pallets, if it's a fixed location, I have to teach a frame for that. And if the conveyor is moving, it's just like the inbound conveyor, but there's a template that teaches all this for me. And if I have a lot of machines, let's say I have 10 machines, I need to go to each of these machines on the pendant to calibrate each of these locations, teaching these 3 positions that are defined here. Kind of how you define a base.
All right. Looks like that is all the questions we have for today. Thank you for joining this webinar session to listen to Chad Ducart on the topic of optimizing picking and packaging applications with KUKA.PickControl. Thank you all, and we will see you on the next one.
All right, thank you very much.
industrial intelligence.